Welcome to our video tutorials for getting started with controllers from STW. In this video, we would like to introduce you to the setup of the Ethernet interface for communication between a Windows PC and controllers from STW. Many controllers from STW offer the Ethernet interface for communication in addition to the CAN interface. We can put this interface into operation in addition to the CAN interface. In the delivery state, an application runs on the controller through which the Ethernet interface already works. So we only have to set up the PC side for this communication path. PCs usually have a built-in Ethernet interface used for communication of the PC with the internet or company network. They are typically configured to obtain IP addresses automatically and are therefore not suitable for communication with our controller. STW therefore recommends the use of a USB to Ethernet adapter. So we connect such an adapter to a free USB interface of the PC. The detection and setup under Windows is executed automatically. We configure the adapter via the Windows function, Settings, Network and Internet. Under Change Adapter Settings, we find the USB to Ethernet adapter we have just connected. Via the right mouse button and Properties, we get to the setting options for the adapter. In the list of used items, we make sure that Internet Protocol version 4 is activated. We click on this and then on the Properties button. Here we can set that a fixed IP address should be used at this interface. For our experimental setup, we have to make sure that the adapter uses the same subnet as the controller. From the information sheet in the starter kit, we can see that our controller is configured to the IP address 172.20.230.120. So we'll assign the IP address 172.20.230.1 for the adapter. For the subnet mask, we take the default values. Now we can establish the hardware connection of PC and controller with the Ethernet cable from the case. The network connector is connected to the adapter on the PC. And the M12 connector directly to the socket on the controller. We pay special attention to a tight fit of the M12 connector to ensure a safe contact of all pins. To test the Ethernet interface, we'll execute a simple command through the Windows command prompt. With the controller's IP address already known, we use the ping command to verify its responsiveness. A successful response indicates the proper functioning of the Ethernet interface. To test the Ethernet interface in the system network with openSYDE, we again use the example project from the TSP, which we already know from the video Getting Started with CAN Communication between PC and Controller. We can execute the same procedures, which we have operated in this video, via the CAN interface, also via the Ethernet interface. We just have to select the corresponding view. Here, in the view ETH, the PC is connected to the Ethernet interface. So we are running the device configuration. When an application communicates via Ethernet for the first time, the firewall may block this, depending on the configuration of the Windows system. So we have to allow this communication. Thereafter, all openSYDE communication works over Ethernet as well. We can flash the application over Ethernet in the same way as over CAN. This runs much faster than over CAN with 125 kilobits per second. And finally, The operation of the dashboards works the same way as it does over the CAN interface. We summarize. Ethernet communication is handled by the application on the controller. In a network using the IP protocol with fixed known IP addresses, the Ethernet interface of STW controllers can be effectively utilized. The openSYDE functions, including device configuration, flashing, and dashboards, are executable through both Ethernet and CAN protocols. I wish you much success with the controllers from STW.